the questions which basically we are going to do today are extremely classical questions. You would have heard about them in your college also, and you would have implemented them as some small mini project in your college days, I believe. Okay, so let's take a look at some of them. So this first queen is very popularly known as, first question is popularly known as n queens. I'll rephrase the question, by the way. So the question says that I guess everyone knows about chessboard, right? Game of chess, you know. So a chessboard is nothing but it is a grid, okay? And its dimensions are square, okay? That it is an n cross n grid. So number of rows will be equal to number of columns. So this is what your chessboard is. Now the question says that you have been given a chessboard of dimension n cross n, and this is mentioned in the input. So if your input is n, if your input is an integer n, that points to the fact that you have a chessboard of dimension n cross n. Okay. Apart from that, n also means one more thing. So this is the first thing that n means, that you have a chessboard of n cross n dimension. Another thing that it means is that you have got n queens with you. Okay, so like there are different players on the chess, right? So you have queens. So let's say you have got n queens, right? Now the question asks you that you have to place these n queens on the chessboard such that no queen attacks the other. So I do not want that the placement is ever being made in a way that one queen ends up attacking the other queen. Okay. Now after hearing this, what is the next question that you should ask me? You should ask me that what is the meaning of attack, right? When does the attack take place and everything? Okay. So if let's say there is a queen over here, now if there is any other queen in the same row, okay, then it will be attacked. Whether it is towards the right or it is towards the left, it will be attacked. Similarly, if there is any other queen within the same column, whether it is in the top or it is in the bottom, it will be attacked. Okay, so if there are two queens along the same row or along the same column, they will be attacked for sure. Apart from that, even if they are along the same diagonal, okay, even if let's say there are two queens that are lying along the same diagonal, still there will be an attack. Okay, and how many diagonals can you see with respect to any cell? There can be two diagonals. Okay, first is major diagonal and second is minor diagonal, because if you are saying that hey, this is a diagonal, then what prevents you from saying that hey, this is also another diagonal, right? So if there is a queen, let's say, which is sitting over here, then again there will be attack. If let's say there is a queen sitting over here, then again there will be attack. So if two queens are along same horizontal line, same vertical line, same major diagonal or same minor diagonal line, sorry, this is major diagonal and this is minor diagonal, same major diagonal and same minor diagonal line, then there will be attack. So you understand when the queens will be attacking each other, right? So you have to be careful enough in placing the n queens in a way that there is no attack at all. Okay, so this is the, this is what question wants from you. Now let us take some example to solve this question. So one thing that I want to tell from here is that in certain questions like this, when maybe you are not getting approach for the, although you might be getting an approach of all the combinations and all the permutations and trying those out, but that will be very expensive, but still it will be right. You can think of, very small version of this problem. So here this is n queens problem. So think of very small values of input and try solving for those smaller values of input. Then it gives you a correct glance of the problem, and then it gives you a better way to write your code of recursion or backtracking, whatsoever you want. So let's start with very small input of n. So when n is 1, okay, n is 1 means your chessboard is 1 cross 1 and you just have a single queen with you. Can you tell me whether or not it is possible to place one queen on a chessboard of 1 cross 1 so that there is no attack? It is quite possible, because there is only one queen, so there will be no attack. Okay, So I can just put one queen over here and my job has got done. Okay. How about n equals to 2? N equals to 2 means that my chessboard is of size 2 cross 2 and I have got 2 queens with me. Can you place these 2 queens such that there is no attack? So you will realize that there is no way. Let's think of it like this. If you place the first queen over here, how many options do you have for second queen? This can you place here? No. This can you place here? No. This can you place here? No. Had you placed the first queen over here, then also there were no possibilities for second queen to be placed, because if you place it here, attack, place it here, attack, place it here, attack. Okay. So for n equals to 2, there is no solution. For n equals to 2, there were no solution. Now think about n equals to 3. Just take your pen and paper. You can't imagine it just like that on the fly. For n equals to 3, do you see solutions? If yes, then how many distinct solutions do you see for n equals to 3? So my n equals to 3 means my chessboard will be 3 cross 3 chessboard, and I have got 3 queens with me. So you can print it in this way. If you are thinking of an orientation like queen, then no queen, no queen, no queen, you can denote by dot character, q dot q dot q. If you want something like that, you can create and you can type that out. Anyone here who feels that there are no solutions? Okay, let us explore that. See, let's say I have to place my first queen. Okay, if let's say I pick my first queen and I place it over here. Okay, and now let's say I go on to second queen. Can you tell me how many choices do I have for second queen now? But before telling that, tell me, if you have placed a queen in ith row, if you have placed a queen in ith row, can you place another queen in the same row? You can never do that, right? So you can think of it like you can perform the placements of queen in a row by row manner. And what I mean by row manner, that you pick the first queen and you place that in the first row. Now for the second queen, you must start from second row, because you cannot place second queen in the first row, right? So you can't place the second queen in first row. So you have to start searching from the second row onwards. So now you have second queen. So how many choices do you have for second queen? So second queen, if you want to place in this row, you can you place here? No. Can you place here? No. Can you place here? Yes, you can place it here. Okay. Now third queen. For third queen, you will move to the third row. Okay. So see guys, you could have moved column by column also. That if you place a queen in column 1, then second queen must be placed in column 2. So you could have moved column by column also, but you could have moved row by row also. Here I am moving row by row. So now for the third queen that I have, third and final queen, I will stick to my third row, because I know that these two rows have one queen each, so no use searching this and this row, right? So now how many choices do you have for the last queen in this row? Can you place here? Attack will be there. Can you place here? Attack. Can you place here? Attack. So corresponding to this kind of placement of first two queens, there are no solutions. Okay, so now let us try out others. So what can be other ways? So if you placed first queen over here, for second queen you just had one option, which was this. Was there any other option left for second queen? No, there was no other option left. Okay, so now let us try changing the position of first queen, and then let us see if I am going to get a right answer. So if I try changing the position of first queen, what will I do is, I will place the first queen over here, and now for second queen, how many options do you have? Can you tell me? Can you place second queen in second row? You can't place that, right? Even if you might argue that, hey, if there is no option in this row, let us go to this row. But if you place second queen in this row, you might want to place third queen in this row, and for that again you will end up having no options. So if at any point of time you see that you are trying to place ith queen in ith row, and in that ith row, out of all the cells, no cell can accommodate that ith queen, that means that corresponding to this placement that you have done, or corresponding to whatever past placements you have done, there are no solutions. So yeah, let us try the third possibility to place first queen. First queen could have been placed here also. So even if you do that, even if you place first queen in this cell, then what happens? For second queen, how many choices do you have? If you are placing second queen in this row, how many choices? You can just place it over here, which is a one choice. But again, do you have any choice left for third queen? No, no choice at all. So corresponding to 3 cross 3 matrix and 3 queens, there are no solutions. So let us then think how we can try to solve this. Maybe let us take one more example. How about n equals to 4? Try that out. Try for n equals to 4. Are there solutions for n equals to 4? If you see that there are solutions, then first print how many solutions are there, and then also you can print a configuration. Yeah, so in fact that is right. So for 4 cross 4, if you try your way out, you will see that, let me first draw that 4 cross 4 matrix. So if I place first queen here, so can you tell me how many options do I have for second queen? I have randomly placed my first queen here. I could have placed here, here, here also. How many options do I have for second queen? If I place my first queen over there, I just have one option, right? And where should I place? I should place it here, isn't it? Now for third queen, how many options do you have? Can you place here? No. Can you place here? No. Can you place here? No, but you can place here. And for fourth queen, can you place here? No. Can you place here? No. Can you place here? Yes. There is no attack. So this is a right configuration. So other than that, if you had, let's say, started your journey by placing first queen in this cell, then you would see that there would be no solutions. Although I am not going to draw that, but you can try that out on your own. You can try placing first queen in 0, 0, which is the topmost left cell. And then when you work your way down the chessboard, you will see that you are not able to place all the queens. Okay. Is there any other solution? Yes, there is another solution also, because if you keep a mirror over here, let's say you put a mirror over here, what does a mirror do? Mirror performs lateral inversion, right? Whatever is left, that becomes right, whatever is right, that becomes left. So if you put a mirror over here, you will end up seeing something like this, where the chessboard has these cells, and now where will this appear? So this will appear over here in this cell. Okay, where will this appear? This will appear over here. This will appear over here, and this will appear over here. Is this also a valid combination? So there are two solutions of it, two solutions to it, and these are the two solutions to it. So first solution corresponded to the fact of placing first queen in this cell, which is 0, 1, and second solution corresponded to the fact of placing it in 0, 2. If you place it in 0, 0 or 0, 3, there are no solutions that you are going to get. So guys, think how I can solve this problem. Now let us think about how input output is going to look like. So you can imagine that there is a 2D character array of n cross n. So a 2D character array of n cross n is going to represent the matrix, and initially the chessboard of n cross n is empty. So I will denote that emptiness by dot 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 dot. Okay. So let's say it is a 3 cross 3 one. So I'll say that initially everything is empty, and now you should return me a character array, a 2D character array consisting of dots and Qs. Okay, representing all the possible correct configurations. So let us think how I can solve it. So can somebody start by speaking of the most basic solution or something like that? What could be the easiest way to solve it? Tell me. Visiting each cell and checking for conflict. Okay, we start placing queens from the left column, and in each column we find the row in which doesn't have a clash. Okay, so you're doing it column by column. Yeah, makes sense. Is there a need to backtrack over here? Yes, there is a need to backtrack over here. Okay, great. So let us try to understand about it. So let's just think of it in this way. We have all agreed that if you place a queen in row 0, I am going to stick to row by row placement. You can do it column by column if you want. So if you place a queen in row I, the next queen must be placed in row I plus 1. Okay, so let us try doing that. Okay, let us say I have a 4 cross 4 matrix which is initially empty. Okay, so I start by placing my first queen. Okay, so my first queen, or let me call it 0th queen, I am indexing from 0. I'll try to place my 0th queen in 0th row. Can you tell me how many options do you see for this 0th queen? If I try to place it in the first row, there are 4 options, right? So what I can do is I can explore all those options out. So I can first try placing my 0th queen over here, so that will make this thing look like this, right? So this is how it will happen, right? Now you would want to make another call, okay, where you would have tried to place your 0th queen over here, okay, but when you are trying to place your 0th queen over here, you would definitely want that this thing gets overridden from here, this thing gets converted to dot over here. And how would that be possible? That would be possible if and only if this thing has been removed from here. So if you say that this action of yours is called as mark, so you mark a cell, okay, and when this entire thing is over, because see, from this node that branch is going to explode, which will certainly have first queen at this particular cell, okay. Now if you want to let go of this, so you have to unmark whatever you had marked. So when this entire function call is over, the last thing that you should do is unmark, so that you can take another choice for the placement of 0th queen in the 0th row, which is to place it over here. Since it's a mirror image, try for n by 2 calls. But let's assume that the question asks you to print all of those. How will you actually determine that you are not going to get a solution from a particular branch? Do you know that beforehand? You don't know that beforehand. Okay, so if the question is asking you to print out all the configurations for you, you might want to try out all the branches, because unless you try out all the branches, you don't know that how many solutions you are going to get, right? So you might want to try those all out and then try to print those out. The only thing that you have to ensure is that your code should be written in a way that you are not getting duplicate configurations from 2 different branches. What I mean by that is, let's say you get a configuration which is correct from here, and you also happen to get a configuration which is correct from here, and both of them are equal. So I don't want you to do that. Tell me, the way I am writing my code, will it ever happen? Will it ever happen that there are 2 different branches which are giving same correct configurations? It will never happen. Why? Because all the correct configurations that will germinate from here will have first queen here, and all these configurations will have first queen here, and anything that has first queen here will be different from anything that has first queen over here. So let's go ahead. Yeah, one more thing. How will this change? This was pointing to the row number where my ith queen was being placed. So how will this change? Let's say that is I. So how will I change? I will become I plus 1, right? Because if you place ith queen in ith row, you will place I plus 1th queen in I plus 1th row. So it will change by 1 unit. So now to place your first queen, you will go to first row, similar to this thing, okay? I'm not going to create this. I'll be doing that later if required, okay? So now you are in first row. So how many choices do you have in first row for next queen? I could say that, hey, in worst case, any guy could have assumed that, hey, my next queen can be placed here, can be placed here, can be placed here, can be placed here, okay? So what I just said, I am going to do that, okay? So if you consider all the choices over here, then you would end up making 4 different calls. In the first call, this row remains as it is, okay? In the first call, you would have tried to place your next queen over here, and then you would have moved on to the next row. In the second call, you would have tried to place your second queen over here, and then you would have moved on to next row. In the third call, you would have tried to place your next queen over here, and then second row, and in the final call, you would have tried to place it over here, and then recurse. But don't you believe some of them are useless and I could potentially prune them? Pruning is as good as not calling them. Yes, very good. So I know that this call is useless and this call is also useless, okay? But whether this is useless or not, or whether this is useless or not, that has not been ascertained, isn't it, guys? I do not know how the future is going to look like. I do not know how the remainder of the chessboard is going to look like when the function call propagates down for these two. But one thing I know for sure, if this goes down, this thing will always remain violated and this thing will always remain violated. So this call and this call must never be made. So this is what pruning is. When I said at the beginning of class, pruning is as good as not making those function calls which are guaranteed to give you incorrect configurations. Okay, so do not make those calls. So what you will actually do is, you will not make these two calls and you will just make these two calls. However, it doesn't mean that you will not get solutions from this and this. Even if you make these calls, eventually you will be getting the solutions and those will be distinct solutions only. But what will be the problem? The problem will be that your time complexity will be very, very high. However, if I stick to that approach where whenever I am trying to place ith queen, I have got how many choices? N choices, because in ith row there are n cells and corresponding to every cell there will be a new function call. What would have been the time complexity of this approach? Take your time and then comment. Or in the easiest way, think of it in this way, that how many function calls would have been there? N raised to power n, right? Because at the first row you would have n choices. So here there would have been n function calls. Now for each function call over here, again n choices. So below this, n square, below that, n cube, and finally n raised to power n. So the complexity would have been n raised to power n, and that would have been too huge. So I can easily cut down this a bit, not much, but I can cut down this a bit, which will, because if you prune this and this, that means you're pruning a lot of function calls, by making only those function calls which are correct. Okay, so again, let's go ahead. So now the call that got transferred from here to here and here to here, now it will try to place the next queen in second row. So how many choices do I have in second row for next queen? Can you just tell me that? Okay, so 4, when you are saying 4, those 4 choices are blind choices, but I don't want you to be blind. Now I want you to only consider those choices that have a potential to give you the answer. Okay, so let us examine them one by one. Let us examine all these cells one by one. Can you place next queen here? No. Why? Because there will be an attack. Can you place here? No. Attack. Here? No. Attack. Here? No. Attack. So how many choices do you see? Are there any choices? There are no choices at all. So if you are at some ith row trying to place ith queen in that, and you see that there are no choices, so what should you do over here? Can somebody tell me? What should I do? Should I simply return? Yes, I should simply return, because there is no option over here, so this should be my return. I should not even print this configuration. Why? Because this is not the right configuration. I should simply return over here. What will happen when this returns? So whenever, so let's say when this function call was made and it was trying to place first queen in first row, and these options were useless, so it came to this option and it placed a queen here, so that action was marked. Now when this function call returns, before triggering next function call, is it supposed to do something else? It is supposed to unmark. It is supposed to unmark what it had marked. So it will unmark, and unmarking will ensure that now when this has been unmarked, so this will be a dot and this will start looking like this. So now it will place the first queen at this particular cell, and now the branches from here will start expanding. So again, what is going to happen in this branch? Tell me, what is going to happen over here? When you have placed the next queen over here, okay, now you will move on to row number 3. Okay, so this is your row number 3. So now you will try to place your next queen in third row. So how many options do you have for next queen in third row? You have one option. And what is that one option? Can you place here? No. Attack. Here, attack. So you just want to place it over here. Okay, so you would just want to place it over here, and then what would happen? After placing it over here, you would make that call. Ensure one thing, whenever you are marking, after making that function call, you are unmarking also. So now it will look like this. Okay, and now this is 4. So now when you are again here, how many choices do you have at this point of time? Would you want to place the queen anywhere? Second position. Can you place it at second position? No, you can't place it at second position, because if you place it at second position, then what is going to happen? There will be an attack. Okay, one more thing. when I was at this particular row, did I just have one choice? No, I had one more choice. I could have placed second queen over here also. So I would want to try out that branch also, but later. Okay. But again here, when you are over here in this particular row, again you don't have any choice. So again you will return, and after returning, unmark will happen. So unmark will remove this from here, and now you would make a call where the next queen has been placed over here. And this is how it would go on and on. Is index incremented by one more unit? Has that happened? 0 and then 1 and then 2 and then 3. I think yes, because these calls that I have made should have come over here, because now when you are at second row, this is your second row. So how many options did you have? You had, so let me erase it. Yeah, this got wrong. So when you are at second row, which is this, how many options do you have? You have just one option, which is to place your next queen over here. You can't place here, here and here. So your next call would have been to do something like this. Dot q dot 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 dot, and then your row number becomes 3. Okay, and then again you will go down from here. This is how you go down. So yeah, corresponding to this choice again, now 3 means that you are at third row. Do you have any choice to place the last queen over here? Do you have any choice? No, you don't have any choice. So what will you do? You will simply return from here. Okay, you will simply return, and then first you had marked, so then unmarked will happen. So this queen now goes away from here. Now you will make another choice if at all that exists. Okay, and if it doesn't exist, that will backtrack and keep on going like that. So tell me one thing, what should be my termination condition? When should I be able to realize that, hey, all the queens have been placed successfully? Okay, I equals to n. So whenever my index becomes equals to n, so first tell me when my index increases. My index increases when I have placed a queen without any conflict in the ith row. So, but if my I has become equal to n, that means, hey, I have placed all the n queens in n rows without any conflict. Okay, so whatever I have printed is a valid configuration. Whatever I have got is a valid configuration, and that is worth being printed out. So I equals to n should simply correspond to my termination condition. So I'll just try to write a very simple code for this. So let's say there is a function called as print n queen. So this function prints all the possible configurations. Okay, this is supposed to print all the possible configurations. I can keep it void. Okay, and it takes in a row number. So, and let's say there is that 2D array declared globally, okay, which is initially all dot 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 dot. Okay, so what should I write first? Should I first write my termination condition? Yes. And what is my termination condition? I'll say that, hey, if my row number has become equals to n, that means I should print the array. If this is the case, then I should print the array, and after printing the array I should return. Okay, otherwise what should I do? Let's say the case were something like this, okay, where you are over here. So otherwise what should I do? Otherwise I should inspect all the cells of that row, and I should make calls for only those cells which are safe to be placed. Isn't it, guys? Yes, no? So how can you do that? Do you need to write a for loop to do that, to examine that which cells are perfect or not? Okay, so now you want to iterate across all the cells of this ith row. So how can you iterate? You can iterate from, let's say this is the cell of column 0, column 1, column 2, so until column n. So my column number goes from 0, column number lesser than n, and column number plus plus. Okay. So what should I do? Should I place the queen at array RC? Should I place the queen and then make the call and then unplace the queen? Should I do that? No, that is not a great idea, because that would be n raised to power n approach. So what should I first do? I should first check whether queen can be placed at this particular coordinate or not. What is that coordinate? R comma C. Okay, so first I'll check for the safety. So let's say I write a function is safe. So is safe function takes R comma C, and this function is written in a way that it will return true if the queen can be placed here. So for this cell it will return true, but for this cell and this cell it would have returned false. So if it is safe to be placed, then what should I do? Then I should place the queen over there. Placing the queen over there means marking that cell with value with a character q. Okay, and now after placing the queen over there, what is the next thing that you do? Let's say you place the queen over here at this particular location, which is this. After placing it, you invoke this function call, isn't it? So invoking the function call means what? You will call print n queen. This array is anyways global, so now you will pass next value of row. What will be next value of row? It will simply be row plus 1, isn't it? Yeah. Cool. Is anything missing in this code? So I should unmark also, because I had many options in rth row. Okay, so when first option has been completely visited, then before you visit second option, then you should unmark the cell that you have marked. So you should do array of rc equals to dot. That's it. This is your do, this is your recurse, this is your undo. Yeah, just this much of code and your job gets done. So this is how you can solve this problem very easily. Okay, tell me one more thing over here. If let's say the question said that, hey, you do not print me all the configurations, rather print me any one correct configuration. I'm just interested in you printing me any one correct configuration. So when your tree would have been growing, you would have wanted to print the leftmost correct configuration and disregard the further calls, isn't it? So how would you do that? How would you do that? I simply want to print any one solution. I don't want to print out all the solutions. If you have to print out all the solutions, you have to visit this entire tree. If you just want to print one solution, you can ensure that, guys, is there a disconnect here, or are you there? Are you able to understand the point? Right? So how do I do that? I can easily do that by having a flag. So you can keep a flag, either you can pass that flag by reference, okay, or you can have it global. So let's say you pass that flag by reference, and that can be a Boolean flag. And that flag, if it is true, it means that a solution has been already found. So please do not use your brain again to find it, okay? And if it is false, that means it has not yet been found, so keep using your brain, okay? So what would happen whenever you encountered this, okay, whenever you found that r was equal to n, then before, you printed your answer very good, but before returning, you should change the flag to true, okay, and then you should return, okay. But just this much is not enough. There should be some line of code over here which is going to prevent the future function calls from being made. So what should I do? The first line of code that I should introduce here should be in this way, that if flag is false, if flag is true. If flag is true, what does that mean? It means that the solution has been found. So please don't do anything, simply return. So what would happen? Let's say you found a solution over here, and now let's say when this call was there, then it was making all the function calls. So the call to this would be made, call to this would be made. So when this call gets made, the line encountered will be this, and it would see that the flag was true because the solution was found over here, okay. So the flag was made true, so this will simply return. Similarly, this will also simply return, right? So this is again like a pruning, where you use if is safe not true for any value, we prune the condition. Yeah, that anyways we are doing, right? That anyways you are doing. I mean, pruning is as good as not making those function calls which are unsafe. So you first check whether that call is safe enough to be made or not. If it is not safe enough to be made, you don't call that, and that is as good as pruning it out. We can place the flag condition in loop as well. This will also stop is safe. Yeah, you can have it there as well. So when you are iterating across all this, there is not much of problem in that. So when you are iterating across all the cells of a particular row, within this, in this if condition, you can have one more, that you are checking that the value of flag is false or not. So if the value of flag is false, then only you are doing all these things, otherwise you are not doing. So that also makes perfect sense, okay. So this was your n queens, and this was a very classical problem.